Welcome to MechTech 40. Today we will study about Fourier series. As you know, this is a pain area in mathematics. So let's discuss it in a simple way. So before starting about Fourier series, let's consider when it is used and how it is required. This is required when a periodic signal can be represented has to be any periodic signal we have to send, or that is the application part. So let's remember that for any periodic signal we need Fourier series. So, and periodic signal can be represented by a set of complex exponential signal. Okay, and if we will come to complex exponential signal, guys, then in case of exponential signal, what we can say that exponential signal is of the form e to the power I theta, and it can be also represented in the form of sine theta, cos theta. Okay, guys, and this is a geometrical form, and this is your exponential form. Okay, and let's study about Dirichlet's condition, but this is also required in case of a function. So it has to satisfy the Dirichlet condition, then we will apply the Fourier series. So as per the Dirichlet's condition, we have to remember certain points like function is finite, single valued and periodic. Function has finite number of discontinuities in one period. Function has finite number of maxima and minima in one period. Function should be integrable in one period. Okay, guys, will be given a period, and in that period function has to be finite. It should not be infinite. There has to be a single valued function, and it is a periodic. That means it will repeat its pattern with certain period. So coming to the mathematical relation or mathematical formula, the general formula we'll talk about. Let's consider a periodic function which has a period of 2L. Okay, guys, and it is from minus L to L. That means the function is periodic with a period of 2L, and it is defined in the interval minus L to L. Okay, then as per the general formula, f of x will be equal to a naught by 2 plus summation n equal to 1 to infinite a n cos n pi x by l plus summation n equal to 1 to infinite b n sin n pi x by l. And what is n? N can extend from 1 to infinite. As the name says, it is a series. So this ranges from n equal to 1 to infinite. So these are infinite terms. Okay, guys, because here we are taking from the first term to infinite terms, and it is a constant term, that is a fixed value. Okay, and this will vary with x, and which will result in a functional value of x, that is f of x. So what is a0, an and bn, which you are seeing here, these are called Fourier constant. Okay, guys, these are Fourier constant, and we generally asked what the value of Fourier constant in the question, or write the Fourier series. So A0 is the constant term in the Fourier series. What is the value? That is 1 by L minus L to L f of x ds. This is the integration of f of x dx. Okay. Then an equal to 1 by L integration minus L to L f of x cos n pi x by L dx. Similarly, Bn is 1 by L minus L to L f of x sin n pi x by L dx. There is a, I would suggest a trick to remember this, guys. Here you are writing an cos n pi x by L, Bn sin n pi x by L. When the question asked what is the value of an, replace an as f of x and put the cos n pi x by L along with it and integrate it, as per the period given. Okay, then let's consider a function or a trigonometric function which has a period of 2 pi and the function is defined within an interval of minus pi to pi. Then L is replaced by what? Pi. So put exactly the same way like the general formula. So f of x will be a0 by 2 summation n equal to 1 to infinite a n cos nx, as x value is pi, L value is pi. So pi and pi got cancelled. So it's a simpler form, that is nx. Okay guys. Now what is the value of a0? As for the general formula, we'll go with 1 by pi minus pi to pi fx dx. Similarly, an will be 1 by pi minus pi to pi. What you will do? Replace an with f of x cos nx dx. Similarly, bn is 1 by pi minus pi to pi fx equal into sin nx dx. Okay guys. Next, there is an add-on point here. If in objective question to solve it rapidly, you can use this concept. Check here. If fx is even, then bn is 0. And if bn is 0, what will happen? Sine term will be 0 in the series expansion. And if fx is odd, then what will happen? An and a0 it will be 0. And even function, what is even function and what is odd function? If f of minus x is f of x and this is even function, and if f of minus x is minus f of x, this is odd function. Okay guys, and if you'll put it like f of x is even, then what will happen? This will if this will, I will put f of minus x, then also this is f of x. Okay, but sine is a odd function, right? So, and it is a symmetric integration from minus pi to pi, where sine will be varies from minus value to plus value, so this will be 0, that is bn will be 0. Similarly, when f of x is odd, if we will go on integrating, this will have 0 to pi value. This is a what? This will be odd function, that is f of minus x will be minus f of x, and so this will be what? From 0 to pi this will be positive, from minus pi to 0 this will be negative. So what we will get? Overall the value will be 0. Similarly for an, the value will be 0. So in the next class we will solve a problem or example of Fourier series. So that's all guys.